Today I'm going to install a series of sensors on the furnace in order to monitor a few things. One of the things that we'll monitor is whether or not the fan is blowing based on this vibration circuit right here, and it's got this little piezoelectric speaker right here which will pick up very, very slight vibrations, and we'll be able to actually monitor the frequency of those vibrations over time. The other thing we're going to monitor is the temperature inside the ductwork. We'll do one on the return and then one on the outbound forced air, and these will get installed inside the ductwork, so we'll be able to monitor the internal temperature and then be able to see that difference. And then I'll probably add a third one, which will be the ambient temperature in the room as well. Haven't quite decided yet. And I'm going to be using this ESP8266. This is actually a little weird one that I bought. I ordered a bunch of them off eBay and they came in this really weird package. Normally it's a little bit, it's got the pins a little bit closer together and not quite as wide. I don't know what the deal is with these. They seem to work okay. I got them for a different project, but for some reason they were having problems connecting to that Wi-Fi, but they seem to work fine at my home Wi-Fi. So I'm going to use this ESP8266, and then I've got this little board here that I had from a different project that I was working on where I just had one sensor, and now I've got two. So this could just do one thing like the temperature. And now what I'm going to do is I'm going to take this off here in a minute and I'm going to put a different one on, so I've got room to be able to hook up these sensors for the temperature as well as the vibration. Now these are the one wire temperature sensors. They've got a range of about positive 125 degrees Celsius, so that's well within range for what we're going to be doing. And because these work off a I2C bus, we can have as many as we want on a single wire. So I just need to have one data input here, which is actually how this is wired up now with the pull-up resistor. And then this here just has, I've got like two pins coming out. Well, actually I have one through the screw terminal, which is essentially a digital out, so it's going to be high or low, whether or not it's vibrating. And when we get into this circuit a little bit later, I'll put this up on the oscilloscope and you can kind of see how that works. But then it's got a little trimmer pot here so we can filter out the vibrations a little bit and be able to kind of tune that so it's more or less sensitive. So what I need to do is I need to add another digital out pin to this. So I'm going to convert it from a 3 to a 4 pin, and then one of those pins will be for the temperature and the other for this. Let's head down into the basement and take a look at what I currently have set up down there. It's kind of a temporary prototype that's been running for probably about a year, and I was using this same configuration for the vibration, and I'm going to be adding the temperature. We're down in the utility room and it's a little bit noisy, so I apologize for that, and I didn't bother to set up the lighting either. But anyway, this is the prototype version that I put out a couple of years ago, and it's got an ESP on it, and then it's got the same little vibration board, but that's on a little PCB, little prototyping board. And that was before I had actual PCBs made. And then right up here is the sensor, the piezoelectric. I've just got it literally duct taped to the side. And then the new addition is going to be the wires coming in here on the right, and that's going to be the two temperature sensors, the short one and the long one. The short one's on the return air, and the long one is on the forced air. So all this big mess of wires from the old prototype is now going to go away, and we're going to put a nice little consolidated version down with some connectors on it, and then we'll also 3D print a case for it so that it looks nice. And the piezoelectric sensor, while it will continue to be probably taped or glued on or hot glued on, I've got a nice little connector for it so that it's not just like right there. You can't really see it, but it's just using some electrical tape onto a piece of plastic and then duct taped onto the side. But honestly, it has worked fantastic over the last year or so. So really no issues with it. Technically, it just kind of looks like a mess. And then on the side of it here, this will be where they get mounted inside the duct. Right now, it's just taped on the side. And you'll notice this metal tape here. This is from when the service technician was out and they did some readings on it before, where he drilled a little hole and then put a little temperature probe in there temporarily. So I'm just going to reuse that same hole, and then I will actually use some black tape to hold the wire in place, and then I'll use some of this aluminum tape in order to hold everything on. So this is on the return air, and then the forced air will be coming from up above. So I took this 3 connector off and I put a 4 connector on. So now I've got the positive on one side, which will be 3.3 volts, ground on the other side, and then in the middle I've got the temperature sensor and the vibration sensor. And the temperature sensor has that pull-up resistor in there as well. And I've currently just have them wired over to D5 for the temperature and D6 for the vibration. And then I do have this LED on the side, which will kind of poke through the side of the case. And it'll just do I think every 10 seconds it'll just blink, just as kind of a little heartbeat life indicator, just so that you can take a quick glance at it and see. The other thing that I'll do is I'll put some blink codes on this. So for example, if it can't connect to the internet, it'll blink 2 times or 3 times. And then if it can't upload data, it'll blink like 4 times or something like that if it can't connect to the server. I've already got the code written for that, but that's just a quick way to do an indicator, since just by quick glance, you don't know if things are working, and it can be a real nuisance. So that's all I've done for the microcontroller. Let's take a quick look at the temperature sensors. So I'm using these DS18B20 sensors. I've used these before. They work really, really well. They're called one-wire digital temperature sensors, and they come in a bunch of different packages. What I'm using for this project is these that come in these little metal cases, only because I had them and they're already hooked on to some leads and shrink wrapped, and these will fit perfectly into the duct work. These have a range of -55 and 125 degrees Celsius, and they work really, really well. What I might do before I install everything is put both of these sensors into a glass of ice water and just kind of calibrate them and see if they're off. I have noticed them to be 1 to 2 degrees off, although for this particular project, that's nowhere near anything that I would be concerned about. So what I have done is I've hooked up, one of them needs a longer cable. So I've hooked up this 3-wire. This is for LED lights. I just happen to have it lying around, and I soldered that on, and then the other end is just open right now. Now what I decided to do, since I've got 2 or 3 hooking up, 2 or 3 of the temperature sensors hooking up into this, because I'll definitely have 2, and I'm thinking of adding a 3rd one for ambient temperature. So what I'm going to do is I'm going to measure everything so that it's just right, and I'm going to use these little connectors. Let me go grab one. I'm going to use these little connectors to connect the temperature sensors up to the microcontroller. These are from LED strips. I bought a bunch of LED strips for a project, and then I ended up not wanting the connectors, and so I just desoldered them all. So I've got dozens of these lying around. And what'll happen is each of the temperature sensors will get one of these connected to it, and then these will come down, and the other end will all get pigtailed together with one common lead going into the microcontroller, and then I can just very easily connect and disconnect the temperature sensors. Now, it's really important to do this when you're dealing with a sensor that is going to be semi-permanently attached, because this is going to get attached into the ductwork. And if I need to take the microcontroller out of service, or I want to do something, I don't want to have to mess around with unhooking everything or even just unscrewing the terminals. Here I can just disconnect them like this, leave the temperature sensors in place, and then pick the microcontroller up. So these all need to be just measured out so that I get the exact length, and then I will cut them and I will put the connectors on the other end, and then we'll be able to start setting it up on the actual furnace. Let's take a quick look at how I've got these wired up. So I've got 4 connectors. 3 of them will be for the temperature, and then 1 will be for the vibration. So the white here is I've converted to black. This will be my ground. The red will become my positive 3.5 volts or 3.3 volts. And then these 3 on the green are going to be for the temperature sensor. And then this single one on the green will be for the vibration sensor. And then on the other end here, I've just put some little connectors. These are generally known as DuPont connectors. They're the same thing that you get for the Arduino kind of breakout board things, but as individual connectors. Now they sell them with these little square, or you get these little square guys on the end. I really don't like them. They're just always a nuisance. And so what I end up doing is just putting a piece of heat shrink on. And honestly, it works so well. I've done thousands, if not many thousands of them over the years, and they just hold up really well. You don't want to bend them, but for just going straight in like something like this into those screw terminals, these work great, and these will actually flatten out when they get compressed down, which will make a really good connection, and they don't come out very well at all. And then in the middle here, I've got some clear heat shrink. I really like the clear heat shrink. You can kind of see, make sure you've got everything all nicely connected in there. So there's the connector on those. Now I just need to measure the wires and get the other end soldered on to each of them. We've got all the connectors put on the wires and everything is ready to go. I went ahead and put a longer wire on this little piezoelectric sensor just so that it could mount up a little bit higher than the board. I'm now going to create and print a little 3D case for these 2 guys. I think they're going to go like this, and then they'll have a couple openings on it. And then this little wiring harness that I made will get wired in here, and then everybody else will get connected up on this end, including the little daughter board here for the piezoelectric vibration sensor. And then on my temperature probes, I went ahead and put the other end of this connector on both of them. This is the one that had the extension on it, and the other one is right here. And this one just has a connector put on, and I've got heat shrink over both of those as well. And then I did 3 of the temperature probe connectors, but I'm probably going to start with just 2, but I've got the option to add a third one in. So now let's go ahead and I'm going to write some code. I'm going to modify it based on my prototype version, and then I'll go ahead and share with you how that's going to work. And then we'll go ahead and build a 3D case for this, and I'll go ahead and get that printed as well. And here's the final 3D printed case. It's based off a different project that I did. I just went ahead and tweaked it a little bit so that it would fit one of these boards instead of 2 of these boards in it. And then I completely forgot to put cutouts for the cables on the back here. So I remembered after I completely printed the whole thing. So I went ahead and just took a hot knife and cut the slots out for that. It's designed to have a little lid that would slide in, either a piece of plexiglass if you want to be able to see inside, or even just 3D print something. And I don't know if I'm going to bother to 3D print one for it, where it's going to be at. Nobody's going to see it anyway. And then on the side here is that little LED, and it'll blink some error codes, and I'll show you the code here in just a second. But every 10 seconds it'll blink once if everything is fine, and then it'll blink twice if the internet's not working, and then 3 times if it can't connect up to the website to send the data. Then I've got the 2 temperature probes, and then I've got my little vibration sensor, and you can see that's turning red on there as it detects vibrations on the desk. And right now I'm just running it off of this little battery pack. You can see it's about 5 or 50 milliamps or so. So it's a pretty low power device. And then we've got the wiring harness over here. So let me go ahead and bring up the laptop, and I'll show you the case, and then I'll also show you some of the code. Let's take a quick look at the 3D design first. This is what I did, and as you can see, it's pretty straightforward, nothing overly complicated. I've got that lip in there so you can slide in a piece of glass or plexiglass, or even 3D print just a straight little lid with some heat vents on the top. Nothing overly fancy. I'll go ahead and put a link to it if you would like to go ahead and make a copy of it. But like I said, it's pretty straightforward and nothing overly elaborate. Let's take a quick look at the code. This code is excessively complicated, and I'm not going to go through every line. I built this for a different project where we had a lot of different temperature sensors, and I have the code auto-detect whatever sensor's plugged in. And obviously in this case, I've just got the one sensor plugged in, but I went ahead and used the code anyway. The big thing I'm going to cover here is how I'm doing the vibration detection, because that's a little bit tricky. And there's a ton of examples out there how to pull a one-wire temperature, so we don't need to cover that here today. But what I'm doing is I'm using a timer interrupt, and I've got it scaled down a little bit just so that we don't really pick up any resolution by having it fire too frequently. But this is going to be that callback on timer. And what it's going to do is it's going to read that vibration pin, that digital pin. In my case, it was D6. And then it's going to detect if it was high versus whether it was low last time, or vice versa. So if the cycle is not the same, so in other words, it went from high to low or it went from low to high, it's just going to go ahead and record that pulse and then record the fact of the new state. And then just for fun, I'm also keeping track of the readings per cycle. And this is actually going to be 8,000. Per second. But anyway, that is completely optional. Now keep in mind, because this is an interrupt, it's going to run no matter what the microcontroller is doing. So you want to be as short and concise as possible. And as you can see, we're not doing any real logic in here. We're just reading the digital pin, we're checking its state, and then we're keeping track of the counter, and then that's it, we're done. Let's jump down to the setup. Here we're just checking to see if we're using the vibration sensor. If so, we're going to go ahead and turn that pin to an input so we can read it, and then we're going to attach that interrupt. And here's where we can see that method that I'm calling, or that function that I'm calling, and then here we're setting up the specific timer, and then this right here, by writing in 10,000 to that timer value, that'll equate to 8,000 cycles per second. So our callback will get called 8,000 times per second. We'll be able to do 8,000 readings based on our sensor. And again, we're only detecting how many times it goes from negative to positive and positive to negative during that 8,000 cycles. So if you want, you can divide that by 2 in order to get the full cycle for each of them. And it really doesn't matter, because all we're looking at is just comparing a number between 1 second to the next second. And I'm actually going to scale that up to actually check that every 10 seconds. But anyway, this is how we're going to go ahead and set that timer up. So now we're down into the loop section, and I've got a couple different segments in here. One is I'm just keeping track of whether or not we're detecting vibration, and we're doing that every 1 second. So we're essentially just checking. And if there is vibrations detected, we'll send essentially an edge case and say, yes, vibrations were detected. And then if vibrations were detected, and then we'll change that back to vibrations not detected. So it gets a little bit complicated, but anyway, we're checking that every 1 second, and we're just using some little local variables. I currently have this set up to upload data to 2 locations. One is Ubidots, which I'll show you in a minute, and the second is just my own MQTT server. And this is I'm using for a backup, but I'm also building some alerts around that, and we can build some additional logic into my backend MQTT server, although honestly a lot of this you can do directly through Ubidots. And so here's the logic for being able to detect if it's being vibrated and then keep that variable somewhat up to date. It'll be at most about 1 second behind. Let's take a look at this read vibrations method, and this is going to run every 10 seconds based on our loop, and it's going to send the amount of pulses per second on average over those 10 seconds up, and then it's also going to try to keep track of whether or not the device is vibrating or not based on the state of the vibrations. So this is broken into kind of 2 sections here. This is the top section. This is a little bit of an edge case where it was vibrating and now it's not vibrating. We want to make sure that we get that set to 0. That way if you graph it out over a period of time, your graph will always end on a 0 before it starts to go back up based on the number of vibrations. Again, it all depends on what you're doing with your data on the back end on whether or not this stuff is important. Here's the payload for Ubidots, and right here you can see we're keeping track of the pulses per cycle, and this is actually reset every 10 cycles or every 10 seconds. And so here we're dividing that by 10. So we're getting the average of 10 cycles or 10 seconds that we're sending up, but we are kicking that back down to a cycles per second value. And again, it all depends on how you want to organize your data and what you're going to do with it. And then here I'm just sending that same payload to my MQTT server. And then down here we've got our edge case where it's no longer vibrating, but it was vibrating. And so we're putting that 0 back out so that that graph will drop back down to 0 if you're graphing it. And then you won't have some weird large angles going from high vibrations to when it vibrates again a little bit later. But you can see that's resetting my is vibrations count or value back as well. Oh, and the last thing we do is we reset the cycles so that it will, in the interrupt, will now reset back to 0, and we can start a whole new 10 seconds after we've sent that data. Let's take a quick look at Ubidots. This is the free version. It's called Ubidots STEM, and it's for personal use and so on. They've got some pretty substantial limitations on it, but for projects like this, it works just fine. And this is the one set of data that I'm collecting. And you can see here's my 2 temperature probes. Now I can come in and rename these later once I actually get it installed. Although honestly, the temperature values will be pretty significantly different. So we should be able to see that anyway. And then here's the vibrations per second that's being updated every 10 seconds. And then here's the state, and 0 is not vibrating and then 1 is vibrating. So if I just go ahead and tap on the desk, you'll see that changes to 1. And if I keep tapping on it, after about 10 seconds, within 10 seconds, we'll get an update here of the vibrations per second. Now keep in mind this is not real accurate for sitting on the desk here because all I'm doing is just tapping the desk and it's not a consistent vibration over a 10-second period. So by averaging them out over a 10-second period down to a vibrations per second, stuff like tapping the desk is completely irrelevant. But it will make perfect sense when we do things like attach it to a HVAC system where we want to be able to keep track of that, where it will be vibrating constantly for hours or days on end, and we want to be able to detect that. And so here's the Ubidots, and if we drill in, and this has been running kind of off and on here for the last couple of hours, we can see just a little bit of data that's starting to trend out. But you can see my range here is a little less than 1 degree Celsius. Now within Ubidots, we can also set up some data conversions, and we can do some really cool graphs and dashboards, but I'm not going to bother with those here today. I'm kind of excited to get this up and running. So I'm going to head over and get this installed, and then I'll show you some pictures of the final version. Real quick before I go install everything, I did make up this long USB cable. I just took an old piece of Cat 5. It's super inexpensive. It's not the best wire to work with, but it's super inexpensive, and of course over a long run like this it's really convenient, and I've got miles and miles of it. And then I've got a bunch of old USB cables. Anytime these break, I always save them because you can always cut the ends off and they're just so convenient. This is a really old one. And so what I did is I took all the solids and I hooked those together, and then I took all of the striped and hooked those together, and then the solid went to positive and then the striped went to ground. And then on the other end I now have the ability to hook up to 4 different USB lines that have complete back on 5 volts to the main power supply here. And I've got a whole bunch of these little tiny ends. These, I had a project where we ended up cutting the ends off and then just using these ends here, and so I went ahead and kept these. So I just got them in a big box somewhere. Very convenient for projects like this because now I can just plug that in and then I've just got that soldered on. All right, let's go get everything installed. I've got everything all mounted. I've got the box sitting on the floor here, and that's actually where I intended to have it, is just sitting on the floor next to my water sensor. And then I've got the vibration sensor attached up here on the face of the return air vent. And then the 2 cables right here are going up to the 2 temperature sensors. And let's take a quick look at those. All I did was try to get them pointing straight in, and so I used some of that aluminum tape in order to wrap around that and hold it in place, and then put a little strain relief here on the side of each of them to kind of hold that in place. And best I can tell, it is kind of pointing straight in, so that should work out perfect. And that's why I use one of these vibration circuits to monitor my furnace and to know when it's running or not running. So I hope you enjoyed that. Next video, I'm going to actually cover this circuit. I'm going to talk about how the circuit works, some of the challenges that you might run into if you implement it yourself, and I'll talk about some of the different versions that I've created over the years. So if you want to catch that, make sure you subscribe to the channel so you don't miss any upcoming videos.